Assalamualaikum warahmatullahi wabarakatuh and good day. So these are the list of my group members. So my name is Muhammad Izzat bin Masami and my group members are Pang Jing Yang, Muhammad Hakim bin Muhammad Isham, Muhammad Yusuf bin Salihuddin and Shafiq Ahmad bin Abdul Alim. So in this video, we are going to present for the LAB2, the flow over immersed body and boundary layer theory. So, boundary layer can be defined as an area at which point the flow is regulated from zero velocity located on the wall to the highest velocity in the flow's mainstream. Boundary layer thickness can be defined as the distance between the wall and the point where the velocity is 99% of the free stream velocity. So, the objectives of this study is to determine the speed distribution for flat plate, to determine the boundary layer thickness of a flat plate subjected to longitudinal flow for smooth and rough surface. But the last objective is plotting streamlines over cylinder, orifice, and wing profile to identify flow conditions. So the scopes for this study is to measure velocity and the height of the water that occurs when water is flowing past the immersed object. And this last one is to estimate the drag force at different flow velocities. That's all from me. Thank you.
Good day to Doctor and my groupmates. My name is Pang Jing Yang, M018221. I would like to present the chapter 2 of our project, the theory part of these experiments. So the external flow of fluid can be defined as the freely developed boundary layer which is surrounded by an outer flow zone with minimal velocity and temperature gradients. The drag force is the component of the combined pressure and shear force that act in the flow direction, whereas the lift force is the component that act normal to the flow directions. The resultant force in direction of upstream force is referred to drag Fd, and the resultant force act in normal to the upstream velocity is referred as lift force. So by understanding this theory, we can find the values of drag force and lifting force by using the equations below. Afterward, we also can find the coefficient of drag force and lifting force by the equations CD and CL respectively. Thank you.
Assalamualaikum and good day. My name is Shafiq Ahmad. I will continue the presentation with the third chapter, which is the method and procedure in the investigation of flow pattern over immersed bodies and boundary layer. Let's go through it one by one together. Okay, the apparatus, as shown in the slide, consists of the following components. First is the mobile rolling frame with bench top, radial fan with power capacity of 0.55 kilowatt, switch box and drawer for small parts, an air intake pipe complete with throttle valve and thermometer, a rectifier, a removable nozzle, a funnel for air inlet, an off-air pipe, a fixture for 16-fold water pressure gauge, and last is the measuring glands for measuring tubes. You can see the parts that is located in the figures besides. Okay, as my colleague explained earlier, this investigation consists of two experiments. The first experiment is the flow pattern of symmetric aerofoil at different angle of attack, also known as the flow over immersed body experiment. The process begins with the experiment setup is depicted as in figure. The aerofoil model is fastened to the airflow bench with screws. Third is to, in order to begin the experiment, angle attack 0 degree is chosen as the initial angle attack. Next, the switch is flip on and the radial fan is free to travel around. Fifth step would be the starting step. The starting speed of the radial fan speed controller is set at 12. Next, the result is tallied and reported. And in order to observe the flow of T-air on the aerofoil, the smoke controller is pressed to emit smoke into the flow. Next, the picture of the aerofoil's flow is captured. Ninth would be the radial fan speed controller is then adjusted by 1 till the fan reaches 19. And the last is the experiment is repeated at 30-degree and 45-degree angles of attack. Okay. Moving on into the second experiment, which is the flow over flat plate experiment, also known as boundary layer experiment. The technique includes the following steps. The first is the experiment setup is depicted as in figure. Second, the smooth surface with flat plate is inserted into the airflow bench. The initial distance is set to 0, and the distance after that is measured. Fourth is the vernier caliper is linked to the pitot tube. And as for the initial data, the pitot tube is attached to the surface of the flat plate. Six is the radial fan is then activated and any data collected and tabulated. Next would be the plate distance is raised by 20 mm to 140 mm, while the pitot tube distance from the surface of the flat plate is increased by 4 mm to 32 mm. And the last is the procedure is repeated for the rough surface. Okay, that's a little bit from me. I'll pass the stage to my colleague in order to further this presentation. Thank you.
Hello, my name is Muhammad Hakim Yaumai Sham, MA1827, and today I will be presenting about Chapter 4, Result and Discussion on Experiment 1. Experiment 1, Flow Pattern of Symmetric Aerofoil at Different Angle of Attack. And for this experiment, we have given three different result of angle, which is angle of attack 0 degree, angle of attack 30 degree, and angle of attack 45 degree with the initial head 137 millimeter. And from the result previous slide, we can calculate our velocity by using this formula. And then we calculate the lift force by using this formula for all the three different angles. And lastly, we calculate the drag force by using this formula, and this is the result that we get. For the discussion, which body create the most smooth streamline? The body that create the smooth streamline is at 0 degree angle, because the flow channel is relatively small and the fluid moves slowly and the viscosity is high. What does the smooth streamline portray? The smooth streamline portray is a laminar flow, refer to the smooth regular airflow patterns that surround an item and indicate the least amount of air disturbance caused by the object motion. What happened to the wing profile at 30 degree angle compared to the normal? The separation point jumped forward and it reached the maximum lift. The phenomena caused the orifice flow to disperse is by the Venturi effect, because of the reduction in fluid pressure that results when a fluid flows through a constricted section of a pipe. For the experiment 2 will be presented by my others group member, Muhammad Yusof. And that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yusof bin Salahuddin, MA18225. So I will continue with the result and discussion for experiment 2, which is a flow over flat surface. First is the experiment 2A for the smooth surface flat plate. The initial head that we use is 278 mm. So here the data of the head for all of the parameter. Next is the velocity calculation. So we use the formula V equal to square root of 2 GH to calculate the velocity. Then here is the result for the calculation for each of the parameter. And then next we calculate the Reynolds number RE. We use the formula rho VL over mu, where the rho is 1.184 and the mu is 1.894 to the power of 10 negative 5. So after we compute, this is the result of this Reynolds number for each of the parameter. And next is the calculation for the dynamic pressure. We use the formula rho G and the difference in head. So after we calculate, here in the table show the result of the dynamic pressure for each of the parameters. And next, here the speed distribution graph for the smooth surface. We plot each of the condition in one table, in one graph to see the difference. Next, for the experiment 2B is a rough surface flat plate. The initial head is 228 mm. So here the head for each of the parameter in the experiment 2B. Next, we do a calculation on the velocity. For the velocity, we use the formula of the square v equal to the square root 2gh. Then after we calculate, here the velocity for each of the parameter. Next is the calculation of the Reynolds number for the rough surface. We still use the same formula as a smooth surface, which is RE equal to rho VL over mu. Then after we calculate, in this table show the result of each of parameter, the Reynolds number for each of parameter. And next is the calculation of dynamic pressure for rough surface. So we use the formula pressure equal to rho G and the difference in head. So after we calculate, here the table show the result of each of parameter dynamic pressure. Then we plot a graph, speed distribution graph for rough surface for each of the parameter in the one graph. Next is the discussion. The first question is explain about the boundary layer thickness in the boundary layer of both surface. The turbulent level and energy loss will be increased if the height of the roughness of a surface is greater than the thickness of the laminar layer in the turbulence flow, or if vice versa. Then it will be smoother and impede minimal effect on the boundary. The second question is what is the distance in the plate before the flow become turbulence? What phenomena could be a reason for this change? When the air flow toward the plate, the air around the plate is resisting shear stress offered by adjacent layer of the plate. Until certain extent, the ability to resist the shear stress will be cut off and intermixing of layer will occur. That will lead to the turbulence. And the final question is what is the difference in terms of result for smooth and rough surface? For smooth surface, there will be lower level of turbulence and smoother because the surface roughness height is lesser than the thickness of laminar sublayer of the surface. Meanwhile, for the rough surface, the turbulence level started to increase because the surface roughness height is higher than the thickness of laminar sublayer. Next is the conclusion. In the conclusion, the experiment was conducted successfully. According to the data, when the fan speed increased, the force and velocity also increase. Another that, when the fan speed is constant, the angle that used increase and the force is increased. For experiment 2, the two types of surface that have been used are rough and smooth surface. When the thickness of both boundary layer increase, the head increase and the velocity also increase. Furthermore, the Reynolds number also increase. So that's all from me. Thank you.